Hello, and welcome to the review for Unit 3 of your Algebra 1A course. In this unit, we talked all about functions, what they are, how to use them, and how they apply in real-world situations. Now, a function is just a relationship between two sets of numbers, but it can represent anything like distance that a car travels over time, or money that is earned over time, or any number of other real-world situations. We had several areas in the lessons, and we talked about sequences. We talked about how to look at functions as a graph, as a chart, as an equation, and using those to make sense of the way we represent functions. There was a lot of vocabulary in this unit. I'm not going to go through all of these, but these are ones that you will want to have in your notes before you start the unit test. These are included in the glossary at the end of your unit, but they are very important to understanding what the questions are asking you and how you interpret or answer those questions. So stop your video recording right now if you want to copy these into your notes. One of the most important things about graphing functions is understanding the coordinate plane. The coordinate plane is separated by two axes, the x going vertically, the x going horizontally, and the y going vertically. They cross at a center point where the coordinates are 0, 0, called the origin. The whole graph is divided into 4 quadrants. Starting in the upper right, quadrant 1 is where both the x and y values are positive. Going counterclockwise around the origin is quadrant 2, where x's are negative, quadrant 3, where both x's and y's are negative, and quadrant 4, where only the y's are negative. To graph a point or find the coordinate of a point, start at the origin where the two axes cross. Move left or right for the x value, depending on whether it's positive to the right or negative to the left. Then turn the corner and move up if the y value is positive, or down if the y value is negative. Remember, there are a lot of words for the x and the y, but they always occur in that order. That's why they call them ordered pairs. The x might be described as the input, the independent variable, the abscissa, the domain. The y value is the output after the function is completed, the dependent variable, the ordinate, or the range. We talked a lot about graphing, but one of the trickiest graphs that you had to do was the absolute value. Now, you'll notice that these graphs are not straight lines like most of the other functions we used. They are V-shaped. That's because in an absolute value function, even negative values turn out to be positive, and so when the change is made, there is a vertex or a change in direction in the graph. The plot here on the left of y equals the absolute value of x has a V-shape centered with its vertex on the origin. And here's a chart of possible values that might be on that graph. The range of this function is y is greater than or equal to 0 because it can never be negative. Here in the center, I've altered the basic graph a little bit by subtracting 2 from y equals absolute value of x. And notice what happened to the graph. It shifted it down 2 spaces. So the vertex is now at 0, -2. And here's a chart representing some possible values for this graph. Anytime you have a number being added or subtracted outside of the absolute value marker, it will shift it vertically up for positive or down for negative. There is another possibility where a V might be flipped upside down. What happens in that case is there's a negative sign in front of the absolute value markers. So even though everything inside the absolute value marker will be positive, when you apply the negative sign outside of that, it will always be negative. The shift up or down is the same as with the basic function. For a positive number, such as in this case, it shifted up 3 spaces. If it were negative, it would have shifted down, but it will still remain upside down. The range of this function in my example on the right is y is less than or equal to 3. Now, slope is what we talk about when we have a linear function, a piecewise function, or even an absolute value function. The slope has lots of names. It could be called the average rate of change. It could be called the rate. It could be called the price per pound, something like that, that changes the x values regularly or in a consistent way. Just looking at a graph, you should be able to tell if it's positive, negative, zero, or undefined. So here on the upper right, I've got some examples. An uphill line going from left to right would be a positive slope. Going downhill from left to right would be a negative slope. A slope that is horizontal has a zero slope, as if you were driving across a flat road through Kansas. Whereas a vertical line would be an undefined slope. And you can even imagine this if you were driving along that road and you got to a cliff. You can't drive up it. Your car would flip over backwards. So that's undefined. Now, a slope in general is just the ratio of the rise to the run, or the vertical change over the horizontal change. You should be able to find the slope from a graph, and I've got an illustration down here in the bottom right. If you find 2 points on the graph that cross at grid lines, or if you're given the points, you can count the spaces from one point to another. Here I'm going to be moving from the point -2, -1, and I'm first moving up because that defines the rise. I want to get up to the level of the other point. So from -2, -1, I would go up 1, 2, 3, 4 spaces until I reach the level. Well, it looks like I'm going to go up, 4 spaces until I get to the level of the point 4, 3. Then I'll change direction and count the number of spaces I go for the run, or the horizontal change. And it's 1, 2 spaces over to the y-axis, and 4 more over to till where I reach the point. So I've gone a total of 6 spaces. So I've gone up 4 spaces, to the right 6 spaces, so the ratio would be 4/6. And just like a fraction, you can reduce the ratio, so in this case it would be 2/3. What if you didn't have the graph, or you hadn't graphed these points, and you want to find the slope from just the points that are given? Well, there is a formula that you should have in your notes. It subtracts the 2 y values, because essentially that's what you do when you measure the vertical change, and it puts it over the subtraction of the x values, which is the change in horizontal, or the run. So the formula is y2 minus y1 over x2 minus x1. Now, it doesn't matter which point you start with, as long as you're consistent. In this case, starting with 4, 3 and moving to -2, -1, I would subtract the y's, 3 minus -1, and you know that subtracting a negative number is the same as adding, so 3 plus 1 is 4. And then I would move to the x values and subtract 4 minus -2, which is the same as 4 plus 2, or 6. The same ratio we calculated by counting. And then reducing again, it would be 2/3. Now, if you know the slope of one line, you also know the slope of many related lines. If 2 lines are parallel, they have the same slope. They will never intersect. Their slopes are always the same. Here on the left, I've got a couple of parallel lines and their corresponding equations. And because the slope shows up in an equation as the coefficient of x when it's in the slope-intercept form, you can see that these 2 lines have the exact same slope of 2. One of them says plus 3 after that, one says plus 1, which means they pass through the y-axis at a different point, but their slope is the same, so they will be parallel and never intersect. Now, if a line were perpendicular to another line, there is a relationship between the slopes. One of the lines will have a slope that is the negative reciprocal of the other one. So in the case here on the right, I've got a line that has a -3/2 x for the one that's negative. And then if I flip that upside down to get the reciprocal, that would be -2/3. And if I take the negative of that, I get +2/3. So the slope of a line that's perpendicular to the first one would be 2/3. If you are given a problem, and you will have a couple in your test, you'll be given an equation of a line, and you'll want to find the slope of a line that's parallel to it and the slope of a line that's perpendicular to it. Well, easy peasy, the slope of a line parallel to it is the same as the slope of that line. Finding the negative reciprocal is a little bit more complex, but the examples that you're given in your test are usually y equals 4 or x equals a number. So you don't see a value of x with a coefficient, which is how I told you to look at an equation to find the slope. So imagine that you are given the graph y equals 4. That's where y's value is always 4. It doesn't tell you how x changes because this is actually a horizontal line. It's 4 spaces up from the origin and continues along where the values of y are always 4. Now we know from a previous slide that the slope of that line is 0. You can't take the negative reciprocal of 0, it would just be 0 again. So in this case, you have to realize that the perpendicular line to a horizontal line is a vertical line, and the slope of a vertical line is undefined. So in this case, if you find a slope of a line is 0, the slope of a line that's perpendicular to it will be undefined, and vice versa. If they give you x equals 2, which would be this blue line, then you know that a line parallel to it would also have an undefined slope. A line parallel to it would have a 0 slope. The slope-intercept form is the form that I've been showing you so far on this presentation. It's in this center box, y equals mx plus b. It's a very useful form for writing equations of lines because it shows you immediately what the slope is and what the y-intercept is, and allows you to graph it easily, to understand it easily. But equations don't always come in this form, so you need to be able to change them back and forth from one form to another. They refer to the general form, which I've got listed here on top, as where all of the terms of the equation are listed on one side with 0 on the other. The x term, the y term, the constant term are all grouped on one side. In addition, there will never be a fraction in that form, and the first term, the x term, will never be negative. So you can change an equation in the same way that we've changed equations in algebra to solve for certain variables and move them from one form to another. Since I said that this slope-intercept form is the most helpful, take a look at how you would change this equation on the top into this form. The main focus or goal is to get y isolated on one side of the equation. So I want to get rid of both the 3x and the 10 that are being combined with it. The 3x is positive, so I'd subtract that from both sides. The 10 is being added, so I would subtract that from both sides. Now I have negative 5y, and remember, when you remove or move terms in an equation, you need to keep the operation sign with it. So this one had a subtraction sign in front of 5y, so it will remain as negative 5y on the left. And now instead of equaling 0, it equals negative 3x minus 10 because I've subtracted both those terms from both sides. Y is not quite isolated. It's still being multiplied by negative 5, so you need to do the opposite and divide both sides by negative 5, giving you y isolated on the left, and dividing both of the terms on the right by negative 5, you get positive 3/5 x, because a negative divided by a negative is a positive, and positive 2 or plus 2, because negative 10 divided by negative 5 is positive 2. Now your equation is in the slope-intercept form. You know that the slope of this one is the m, or the slope, is 3/5. You know that the 2, which is in the place of b, is where the graph will go through the y-axis or the y-intercept. To graph it, start out at 0, 2, the y-intercept. Use the slope to find the second point on the graph, similar to what I've graphed here at the bottom of the slide. Now, you can write an equation, you can make a chart, you can make a graph from any of the other representations of a situation or a function. So in this case, the one that we were just looking at, if you know that the slope of a line is 3/5 and it passes through a certain point, you can write an equation. Start out with what I call the skeleton equation, y equals mx plus b. Replace what you know. Slope is 3/5, so put that in as the coefficient of x. But you don't know b yet. They gave you a point, but it isn't the point of the y-intercept. So a little bit more calculation is required. Since every point on the line will make the equation true, we can use this point, -3, -1, by substituting the -3 for x, the -1 for y, and then solving the equation to find b. If we do that, -1 is on the left where y was. 3/5 times -3 is -9/5 instead of the mx, plus b. The only thing we have to do to find b is to add 9/5 to both sides to get 4/5 equals b. So now we know that this graph, or this equation, or this function is going to be passing through the y-axis at 0, 4/5. So we can rewrite the equation as y equals 3/5 x plus 4/5. Now, if the slope turns out to be 0, remember that there's not going to be an x term because 0 times x is 0, and you would just have y equals a number, and just like in the last slide, that's going to be a horizontal line. You can also change back and forth from the slope-intercept form to general form. To change it, you have to move the x and the y terms or any constant terms to one side, usually the left, and you want to clear the fractions. Remember I said fractions are not allowed, no negative numbers on the x. So by multiplying both sides of this original equation, you would get 3x equals y. And then by moving y to the other side, you could subtract it and get 3x minus y equals 0. And these are generally given in the form of the x term, the y term, the constant term, and then it always equals 0. Let's say that you're given 2 points and you're not given the slope. Can you still write the equation? Can you still graph it? Absolutely. In fact, graphing is pretty easy because you just put those points on your graph paper, draw a line in between, and you've got it. But there is a way mathematically to calculate the slope so that you can write it as an equation as well. So in this example, you're given the points 4, -1 and -2, 3. You will subtract the y terms on the top of your ratio to represent the rise. You'll subtract the x terms on the bottom of your ratio to represent the run. And in this case, I'm going the second one to the first one. So 3 minus -1 would be 3 plus 1, or 4. -2 minus 4 is -6. So in this case, it's 4 over -6, and that reduces to -2/3. Then set up your equation using that skeleton formula, y equals mx plus b, and replace the m with -2/3 x. Go back using the same steps we just did in the last slide. Put in the x and y coordinates of one of the points. It doesn't matter which one, because remember, every point on the line will make this equation true. Solve for b. In this case, it turns out to be 5/3. Rewrite the equation using the slope and the y-intercept. Becomes y equals -2/3 x plus 5/3. You can change this to general form using the same algebraic properties of equality. Multiply everything by 3 first to get rid of any fractions. Then move all of the items to the left side using the opposite operations of what they currently are. Now, when we talk about functions, I told you that they were a relation between two sets of numbers. A function is a special type of relation, however, where every x value has only one y value. You can think of it as like a machine. You put in one value, you get out a value. You're not going to be confused and get out more than one value, because that would not be a function. So here are some examples. F of x equals 3x squared minus x. You might be asked to determine if this is a function. You might be asked to evaluate the function. There are many things that you can do. One thing you'll see is functions are always written as f of x or g of x or d of x. That just means a function of x. Don't confuse this with f times x, even though the x is in parentheses, and sometimes we use parentheses to mean multiplication. It just means whatever that x is going to be what you're going to be solving for. In this example, I've got 3x squared minus x. we're going to be using the value of -2 for x. That just means I'm going to replace everything in the equation where the x is in the equation with -2. So instead of 3x squared, I've got 3 times -2 squared. And instead of minus x, I've got minus -2. Just substituted those in. Remember, in the order of operations, you must do the exponents first before multiplication. So in this case, -2 squared is 4. Minus 2 becomes +2. And 3 times 4 is 12, plus 2 more is 14. So f of -2 equals 14. Remember, it isn't f times -2, it's f of -2 equals 14. There is a test that you can use to determine if any graph is a function. You can draw a vertical line through the graph just to make sure at any point on the function it only intersects one time. The reason is because if it passed through more than once, you would be hitting the same x value more than one time at a different place, meaning that it would have a different value of y, and that would not be a function by definition. Now, a function doesn't have to be a straight line, even though that's what we focus mostly on in this unit. It could be a parabola, it could be a quadratic equation, it could be one of these fancy curves, as long as it obeys this rule about having only one y value attached to each x value. How can you tell the difference between a linear and a quadratic function? Well, a linear function is just like the definition of linear, means it forms a line. A quadratic will form a parabola. And you can have a combination. We saw this in our piecewise functions unit. In fact, piecewise functions are one that gives students quite a bit of trouble, and in your test you're required to graph a couple of these. So before you open this test, make sure, if you're going to use Desmos.com, which I've recommended to many of you as a graphing program, that you have that open in another tab, and that you're able to use the tools inside that app to draw your graph. There is a way to put restrictions on your graph. You can figure that out. That's great. I haven't yet found a way to put endpoints on the graphs. So if you choose to use Desmos for your graphing instead of doing it by hand, you will have to provide me an explanation of where the graph starts and ends, what kind of endpoint is on it, if it's solid or if it's open. So you can see in this graph, if you graph this function, you would get a parabola or a piece of a parabola and a piece of a line that overlap where x equals 3. Because they overlap where x equals 3, we know that one function can't have a y value and one will. So the open dot is the endpoint of the function that does not actually reach 3. And you can see here that the conditions for the x squared plus 2 section of the graph only goes up to where x is less than 3. So 2.9999, but never quite reaches 3. So the parabola ends with an open dot at 3. And if x actually equals 3, it's going to shift down into the next category, and the equation will be f of x equals x minus 4. So if it can equal 3, you'll have a solid endpoint on the linear part of this piecewise function, and that will continue up to 7. And the same condition exists at the 7. Your function will never quite reach 7, but it will get very, very close to 6.99. Now, if you're asked for the domain and the range of a piecewise function, it can be a little bit tricky. In this case, the domain can go from -5 up through 7. There are no gaps in it because it goes up to where x is less than 3 and then starts again at x equals 3. So it will extend from -5 all the way to 7. There is a square bracket on the side where x equals -5 because it can equal -5, but only a parenthesis on the opposite side because it never quite reaches 7. So you have to indicate that somehow when you write your domain and range. Figuring out the range, you would have to figure out the values when x equals -5 and 7. And you can see that this is going all the way up to 27 up here at the top of the graph. And the lowest point would be where x equals 3 down here at -1. Be able to graph and determine the domain and range of any function. Here I've got a linear function, f of x equals 2/3 x minus 3, and just a heads up, if you've got a linear function, there are no restrictions on what the x values and the y values can be, so that means the domain and the range will be all real numbers, or basically infinity. Now, making sense of word problems is what most students have the most trouble with. This is the case with functions as well, but this is the whole purpose of functions, to take a real life situation and to write an equation that can be used to show the change over time, or calculate how much it's going to be in your bank account, or how much you're going to owe, or how much interest you're going to pay, or what the temperature will be, or any type of situation. So this is an essential skill that you want to have. My advice for word problems is to read through them carefully the first time without writing anything. Look at the last sentence, which asks you what you are supposed to do. Then go back and fill in the information with the data that's provided. Here's an example. Whenever you sign a lease for an apartment, you typically have to pay a security deposit before you even move in. That's in case something happens, etc. One apartment building has apartments that rent for $750 a month and a security deposit of $300. Write an equation to represent the situation described. Well, we know that you're going to pay that $300 up front, but you're not going to continue to pay it every month. So that's called a constant. It exists there, but it's not going to be paid every month. Whatever is going to be paid every month is going to have to be multiplied by the number of months that you're renting it. So for instance, over a year period, you would pay 12 times 750, because that's 750 times 12 months, plus the $300 you paid in the beginning. So that is going to represent the amount that you would have paid over the course of a year, or however long you rent this apartment. Your equation would be f of x equals 750x plus 300. Here's another one. You're 495 miles from home, and you're driving toward home at the average of 45 miles per hour. Whenever you're given a rate like that, you know that's going to be your slope. How long will it take to drive home if you maintain the same speed? Hint, when you reach home, the y value is 0. So we know that the y value, or where f of x exists, is going to be the distance remaining, or the length of time remaining. So you put your total, 495, that's a given. It's not going to change. You have that 495 miles from home. You're going to subtract from it the hours that you have, or the miles that you have driven. The miles are calculated by multiplying 45 miles per hour times the number of hours that you have traveled. And in this case, 495 is the total, so you're going to subtract 45x. Once you do, you can solve this equation by adding 45x to both sides, dividing 495 by 45 to get x equals 11, and that is the length of time it takes you to drive home if you maintain that same speed. You had one section on inverse functions. And even though we didn't go into depth about how you would use your inverse functions in a real life situation, it is important that you have this skill because you'll be using this a lot in the future. The first step to creating an inverse function is to take your original equation, replace the function nomenclature, the d of x or f of x, with y. The reason is because I'm going to ask you to exchange your x and y in the next step, and some people get confused because there's an x in the f of x and there's an x in the equation. So change it to y to eliminate the confusion, switch your x and y values, and then you're going to go back and use your equation skills to solve for y. In this case, I exchanged x and y and got x equals negative 2y minus 6. I had to add 6 to both sides. I had, let's see, I want to get y by itself. I needed to add 6 to both sides and divide both sides by negative 2. It looks like what I did here first is I added the 2y to the left-hand side and the right-hand side to move it to the left. Then I subtracted the x from the left-hand side and got it to be negative x on the right. And then I divided everything by 2. So I ended up with y equals negative 1/2 x minus 3. You can rewrite the equation using d to the negative 1, which means the inverse function of d of x, equals negative 1/2 x minus 3. Now, graphs tell a story. When we're looking at a rate of change, we know that there's a story behind these graphs. So in this case, if you saw that rain was falling steadily all day, every day, and you were accumulating 2 inches of rain every hour, that's going to be a very steep linear pattern. At the end of 1 hour, you'll have 2 inches. At the end of the next, you'll have 4. At the end of the next, you'll have 6. This sounds like a hurricane or something drastic happening. However, if you were told that 2 inches of rain fall every other day, you're going to have 2 inches falling on day 1, none on the next, 2 on the next, none on the next, and so it would be vacillating back and forth. Both represent a function, but they tell a different story. One special kind of function is called a direct variation. It always occurred in this format, y equals kx. K is the constant of variation, also called the slope because it's the coefficient of x. And notice that no other constant is being added or subtracted in this equation. That forces this linear equation to pass through the point 0, 0 because it will never have a y-intercept. It'll always be 0. So if you're told if y is 5 when x is 2.5 and that y varies directly with x, you can set up your equation y equals kx, put in the numbers that you know. Here we know 5 equals k times 2.5. Solve for k, and you've got your constant. That will never change. Then if you're asked to find y when x is 10, you just put it back into a y equals kx equation using 2 for k, and you'll find out that when x is 10, y is going to be equal to 20. We had a short section on arithmetic sequences. Remember, an arithmetic sequence is when the same number is added to each term in a sequence, creating the next term. To find the common difference, you subtract the second value minus the first value, and that tells you what is going to be added each time. When you use an equation to find a very distant term, you've got a few things to identify to use the equation. A of n, the function, is the value of the term you're wanting to find. The lowercase a is the first term of your sequence. N is the number of the term that you want to find, and D is the common difference, which I've already told you how to find. The equation then is A of n equals A plus n minus 1 times D. Remember, you're always multiplying the common difference by 1 less than the term you're finding because you've already got that first term added. So if you needed to find the 30th term of a sequence starting 1, 7, 13, 19, you could go ahead and add 6 30 times and you would eventually find it. But you can also use this equation by saying, well, a of 30 equals 1, that's the first term in the sequence, plus 1 less than 30, which is 29, times the common difference, which is 6, and you automatically calculate that it would be 175. Now, you're going to be asked to graph a few things on your test. Remember that you have to upload those. Many of you have been writing your graphs out by hand, which is fine. If you do, just make sure you have a way to upload it. You can either take a picture of it and upload it directly. If it's too big, you can paste your graph into a document and upload the document. If it doesn't upload correctly, if you've got it in the wrong format or something, it's not accepted, then go ahead and send it to me by email. You can even text it to me, or if you're using Desmos for your graphing, at the upper right hand corner there's a little square with an arrow that says share. When you hover over it, that will give you a link that you can include. Just remember, if you use Desmos, you need to explain what your graph is if it's a piecewise function, because I won't know where those endpoints are, and that's an important part of your complete answer. Let me know if you have any questions about anything that I reviewed in here or anything in the unit that I didn't touch on in this review, because I would love you to feel really prepared when you open up this unit test. You are required to call me at the end of this lesson, so make sure and get your questions in order. Make that phone call. I'll give you a little hint about something that you might have a question about, or clarify it if you need that. So that being said, I'm looking forward to hearing from you, and good luck on the test.